Yeah, hello, good day. You're welcome to Chem Class 101. Um, this video is presented to you courtesy Shedland Tutors. We will be discussing today in this video the Waec Chemistry Practical Paper 3, Alternative A for this 2026 Waec Practical Exam that is upcoming. All right, so in this video we will be discussing the paper 3 question 2. So let's hit it. The usual credit will be given for strict adherence to instructions, for observations precisely recorded, and for accurate inferences. All tests, observations, and inferences must be clearly entered in your answer booklet in ink at the time they are made. Please, for the sake of students who do not understand, there is a reason why the instruction strictly emphasize that you should write these in ink. Please keep your pencils away from these exams to avoid losing marks. So real quick, C for this exam. C is a sample of an inorganic and an organic compound. Carry out the following exercises on C, record your observations, and identify any gas or gases evolved. State the conclusion you draw from the result of each test. Now, these are the questions that the likely questions you will be encountering. First, put all of C in a test tube and add about 5 cm cube dilute trioxynitrate 5 acid solution and allow to stand. Filter the resultant solution and keep both filtrate and residue. Test the filtrate with litmus paper. Divide the filtrate into 3 portions. To the first portion, add NaOH aqueous in drops, then in excess. To the second portion, add aqueous ammonia in drops and then in excess. To the third portion, add dilute HCl, warm the resultant solution, and allow to cool. To the residue in a test tube, add iodine solution. So we are going to start by preparing our table with the tests, observation, and inference. Do well to draw the horizontal lines and vertical lines properly unless they are provided for you, but I don't think Waec has started providing them. They just leave space for you to enter those. So do well to ensure that your test, observation, and inference are properly, with a rule, you draw the straight lines accordingly. So we are going to start with the first test, C plus NHNO3AQ. Please note, it is important that you state AQ there for solutions. If a solution is used, it's important you state AQ to avoid falling into the trap of what we call solid tests. Okay, so the exam require that you state these things as they are used, and because you are using aqueous nitric acid, it's very important that you put the AQ. You may lose some marks on your observation and inference if you do not put the AQ there. So what happens when we put this? First, you are going to collect a spatula full of C in a test tube. You are advised at this point not to use your entire C, okay, so that if anything happens, maybe by mistake you do what you are not supposed to do with the sample you start with, and you need to start afresh, you still have some sample to fall back on. So you are advised to divide your sample given into 2, use half, all right, so that you have something to fall back on in case of eventuality. So place a spatula full of C in a test tube, then add trioxonitrate 5 acid. I don't know if you can see the picture there, but on adding trioxonitrate 5 acid, bubbles would be observed. And of course, what do we report in this case? We say effervescence occurs. But every time an effervescence occurs, or anytime you report the occurrence of effervescence, which is the bubbling, you must give some characteristics of the gas that is responsible. Now, a colorless, odorless gas which turns lime water milky is evolved. What do you derive from this? The gas is CO2. That's carbon dioxide. All right. Then this is from trioxocarbonate 4 ion or hydrogen trioxocarbonate 4. Solution AI plus filter. You have to filter the solution, and to filter the solution you will need to of course you're going to prepare your filter paper, you know, fold it into quadrants, then flip it open to form a cone. 3 leaves to 1 is going to form a cone. Then you seat it carefully into your filter funnel, then filter the solution obtained from the first test. Then after the filtration, it's very important that you report. Every time you filter, you report the color of the residue and the color of the solution obtained. In this case, white residue is obtained, colorless filtrate is also obtained. It's very, very important that you report this. Now, this is you may or may not need to present this, but I usually advise my students it's better to write more than to write less, because there could be a mark for it you may not know. So the solution you are filtering is a mixture of soluble and insoluble substances, so we will want to report it as such. So the next step is we are going to divide our filtrate into 3 portions. Now, to one of the portions, we are going to add sodium hydroxide solution in drops, then in excess. Be careful to note again, I emphasize that the NaOH has AQ as a subscript, indicating that it is an aqueous solution we are dealing with. If you write NaOH without the AQ, you may stand a chance of losing some marks on account of solid test. So this is sodium hydroxide. We will apply it to our sample solution. You will see a white precipitate. Again, I'm going to advise that you avoid the use of abbreviations by all means. Abbreviations make you look unserious. So precipitation should be written fully, okay, as against PPT. All right, so a white precipitate would be formed. So what do we write there? We say a white chalky precipitate is formed. But what is this precipitate, or what do we infer from this precipitate? Because it is white and chalky, it is not gelatinous, it is white and chalky, we suspect Ca2 plus or Pb2 plus ions. These are the 2 ions that will form white chalky precipitate with sodium, aqueous sodium hydroxide. Now, in excess, we have to check again. In excess, what happens? In excess, we notice that the precipitate will dissolve. And if the precipitate dissolves, you report as your observation. Remember, your observation is not an explanation of the chemistry. Your observation is what you sense with your sense organs. So you will see that the precipitate is soluble in excess. And precipitate being soluble in excess indicates that it is lead 2 plus ion, all right, not Ca2 plus. So put it down there that it is lead 2 plus ion. Now we go over to the next test. To another sample of the filtrate, you will add aqueous ammonia, first in drops and then in excess. You must be very careful with this. Drops means just few drops, just a little per time, then you observe real quick. All right, so when we do this, this is our aqueous ammonia with the test sample, which is a colorless solution at first. Then on addition of ammonia, we notice a white precipitate, that does not dissolve in excess ammonia. It does not dissolve in excess ammonia. And because it does not dissolve in excess ammonia, we're going to report that the white precipitate formed and it's insoluble in excess ammonia. Now, if the white precipitate is insoluble in excess ammonia, of course, that is Pb2 plus once more, Pb2 plus. But we are going to run another test, a confirmatory test, just to be, to be double sure. All right, the exam might come up with this confirmatory test. To the filtrate still, you add dilute hydrochloric acid, so again HClAq, then you warm, then you cool. Now it's very important that your report comes up neat. So you will notice that I placed the filtrate plus HCl on a separate line, then the warming on a separate line, then the cooling on a separate line. And this is because each of these steps have their different observations that I'll want to present on their lines accordingly. All right, so very quickly, this is HCl. We are going to add it to our sample solution. It's going to give us a white precipitate, a white chalky precipitate, right? So we're going to put it there that a white precipitate is formed. A white precipitate is formed. All right, then this precipitate on heating, if you warm it, either place it on a water bath, hot water bath, or you warm it gently, carefully on a Bunsen burner using a boiling tube for safety, or a Pyrex test tube, you will notice that the precipitate will dissolve. So on heating, we will report that the precipitate dissolves. All right, but we are going to wait again for a while to see what happens to the precipitate on cooling. You will see that on cooling, the precipitate will reappear. So the precipitate will form with HCl, it will dissolve on heating, then it will reappear on cooling. Now, this behavior confirms that our cation in this filtrate is Pb2 plus. So we write there Pb2 plus confirmed. Now, very quickly, we will pick up our residue. The residue, of course, we open the filter paper, all right, then scoop the residue from the filter paper. You scoop very carefully, collect just a little amount. It is going to be a little bit sticky. Yeah, it's going to be sticky. All right, so you put it into your test tube, then immediately you get your dropper, collect iodine with your dropper, then drop it on the sample inside the test tube. You will notice a blue-black coloration. All right, yeah, so the one on A, the test tube on A, is what you will see if it wasn't starch. The blue-black coloration actually indicates that the residue is actually starch, because this is the iodine test, for starch. So we'll report our blue-black coloration, of course, then eventually indicate that starch is present. So I hope this video is going to help you. I wish you all the best in your exam. Another video is coming for the question number 1 and the likely questions that you'll be asked in number 3. So stay with our channel, and we are going to feed you with all the necessary materials you need to do excellently well in your chemistry exam. All the best. Ciao.